Okay, so picture the World Championship of Mathematics. We're talking about problems so incredibly hard they're designed to stump the most brilliant young minds on the entire planet. Now imagine a totally new kind of competitor showing up, one that's not made of flesh and blood, but of pure code and silicon. Today, we're diving into a breakthrough that is absolutely changing the game in that exact arena.
Get this. At the International Mathematical Olympiad, the IMO, the world's toughest high school math contest, an AI system from ByteDance did something most people thought was decades away. It formally proved 5 out of the 6 insanely complex problems. That's a massive, monumental leap for AI.
So, the question is, how? How is that even possible? How did an AI crack problems that were literally designed to test the absolute limits of human creativity and intuition? Well, let's break it down.
To really appreciate what a huge deal this is, you first have to understand the core problem here. For decades, getting an AI to do what's called formal mathematical reasoning has been this giant, almost impossible hurdle. You know, it's one thing to calculate a bunch of numbers. It's a whole other thing to prove something is true, logically and forever.
The whole challenge really boils down to this difference. Humans write proofs in natural language, right? They use intuition, they make little leaps that other humans can follow, but for a machine, that's kind of fuzzy. A computer needs something that is 100% precise, rock solid, and written in code, a formal proof. The big problem? Generating that perfect code from a messy, complex math problem is just extraordinarily difficult.
And this is where a critical tool called Lean comes into play. Lean is a formal language, a proof assistant. I want you to think of it as a brutally honest, super strict judge. When the AI writes a proof in Lean and submits it, it doesn't get a maybe or that looks pretty good. It gets a simple, binary, correct or incorrect. And that crystal clear feedback is the absolute secret sauce that lets an AI actually learn and get better.
So, enter the hero of our story, an AI called Seed Prover. It was designed from the ground up with a really clever 2-part strategy to take on this very challenge.
First off, it's not just one system. It's a 2-pronged attack. You've got the main seed prover, which handles general math like algebra and number theory. But geometry? Well, geometry is its own special kind of beast, right? So it gets its own specialized engine, seed geometry. And this part is so cool. It actually thinks in terms of ruler and compass constructions, basically mimicking the fundamental way a human geometer would approach the problem. Now, previous attempts at this sort of thing often tried to generate the entire tangled proof all at once. It was like trying to write a whole novel in one shot, with no chapters, no outline, no editing. It was just a mess. And, you guessed it, it almost always failed.
Seed Prover's approach is just so much smarter. Instead of trying to write that whole novel at once, it focuses on writing perfect paragraphs first. It breaks the problem down, proposing and proving these smaller, bite-sized mathematical facts called lemmas. Each lemma it proves is like a perfect, verified Lego brick. It gets stored in a shared lemma pool, and then the AI can just snap these proven, perfect bricks together to build the final, complex proof. It's brilliant.
But the strategy isn't just about breaking the problem into smaller pieces. It's also about how the AI uses its thinking time. Seed Prover has these different levels of reasoning it can switch between, almost like shifting gears in a car.
You can seriously think of these as study modes. The light mode is a quick pass. It makes fast attempts, looks for an easy win, fixes simple errors. Medium mode goes deeper, really focusing its brain power on those tough lemmas to figure out the structure. And then there's heavy mode. And this is an all-out, no-holds-barred assault on the problem.
When it's switched to heavy, Seed Prover can literally think about one problem for days, generating a pool of thousands of potentially useful mathematical facts and ideas. At this point, it's not just trying to find one path to the answer. It's basically mapping the entire mathematical universe around the problem, searching for any possible path to a breakthrough. The scale is just mind-boggling.
So, all of this sounds super impressive in theory, right? But does it actually work in practice? Well, the results are just staggering.
So let's look at the Mini F2F benchmark. It's a key test for math AIs. The previous state of the art was an awesome 92.2% solved. Very respectable.
SeedProver comes along and scores 99.6%. It didn't just nudge the bar forward, it basically perfected the test. It solved everything but one single problem.
And you see the same story everywhere else. On Putnam Bench, which has really hard undergraduate-level problems, it solved nearly 4 times more problems than the previous best system. On CombiBench, which is all about combinatorics, it tripled the success rate. And looking back at old IMO problems, it successfully proved over 78% of them. It's a total knockout.
And this right here, this is so important. It shows that SeedProver isn't just picking off the easy, low-hanging fruit. It's successfully taking on the hardest problems, the ones labeled P3 and P6 at the IMO, and solving a huge chunk of them. These are the exact problems that consistently stump the world's most brilliant human mathletes.
This incredible performance really brings us to the big picture question. What does all of this mean? Where does math even go from here?
And let's be super clear about something. The goal here isn't to make human mathematicians obsolete. Not at all. This is about creating an incredibly powerful new tool, a co-pilot that can work side by side with researchers. It can check their work, explore thousands of dead ends in minutes, and maybe even spot new connections that a human might take a whole lifetime to find.
The team behind SeedProver's already setting its sights even higher. They said it themselves. They're now shifting their focus from problems we already know the answer to tackling the great white whales of mathematics, open conjectures, the unsolved mystery. And that leaves us with this really profound, kind of mind-bending thought. For all of human history, progress in math has been limited by the speed and energy of the human mind. Now we have this tireless, logical co-pilot that can reason at a world championship level. So we have to ask ourselves, if AI can help us solve our hardest known problems, what entirely new kinds of mathematics, what beautiful, unimagined ideas will it help us discover next?